Number one, what is equivalent resistance? So equivalent resistance is the total combined resistance of a circuit. So we talked about V equals IR. We talked about voltage as being the amount of energy given to a circuit. We talked about resistance as being the total amount of energy that's like being used. And we talked about current as the motion of that energy. So equivalent resistance is what if we combined everything together, right? In the circuits you didn't just have one light bulb. You eventually ended up with two light bulbs. So it's the total combined resistance of what those two light bulbs represent. So it's all of them put together. So how do you find equivalent resistance for a series circuit? This is going to blow your mind, okay? Be prepared. Mentally prepare yourself. Here we go. Ready? Resistance total for series is resistor 1 plus resistor 2 plus resistor 3 plus whatever else there is. You add. I know. It's tough. Hope you guys can handle it. You can't? It's too much for you, Franchette? Yeah. If it was 2, you could do it, but 3 is just too many. I'm with you. That's how I feel. Okay? Literally, you add them. Okay? So let's do an example. I know you're going to need it. For 3 resistors in series, 1, 2, and 3 amps, find the equivalent resistance and the current and voltage. Now this is where it's going to get a little bit tricky. It's actually pretty easy, but you haven't thought about doing it this way before. So let's find the equivalent resistance first. So we're going to call that A. So let's find A first. Okay. The equivalent resistance for a series circuit is all of them added together. So 1 plus 2 plus 3 equals 6. Congratulations. You did it. You solved the problem. Proud of you guys. Okay? But then it wants to know the current and the voltage. Okay. I should have been more specific on this one. I'm going to need to make a change to that. No, not that one. Yes, this one. Okay. I forgot to tell you how much the voltage of the circuit is. So let's tell you what the voltage of the circuit is. So the voltage of the circuit is 3 volts. Okay, so how do we find the current and the voltage? Let's just go ahead. Let's make this simpler. Let's just find the current. Let's make it simpler for right now. And let's just say the current for the circuit. I'm going to simplify things down. Current for the circuit. There we go. Let's make life simple. Okay. So how do we find the current? Well, we use V equals IR. So the voltage is the voltage of the circuit, which is 3 volts. I is the current for the circuit, which is what we're solving for. And R is the resistance, which is 6. So divide 6 to both sides. I equals 0.5. There we go. Easy enough. Add them up to get the total resistance, and then use V equals IR to find the current. So far, so good. Carson, put the phone up for me. Thanks. All right. How do we find the equivalent resistance for parallel circuits? You add them up. However, you can't just add them up regular. You have to add them up like this. 1 over R parallel equals 1 over R1 plus 1 over R2 plus 1 over R3 plus whatever. This is not as easy. It gets kind of tricky, and you have to be really, really careful. I'm going to show you a couple of tricks that will make life easier for you. Okay? Let's go ahead and do number 5. So 3 resistors in parallel, 1, 2, and 3. Find the equivalent resistance and the current. And once again, voltage is 3 volts. Okay, be really careful. You're all going to be tempted to say resistance is 6 amps and current is 0.5, or resistance is 6 ohms and current is 0.5 amps. It's not. It's a parallel circuit, not a series circuit. They're not the same. Okay, so be really careful just automatically assuming. What we have to do is we have to add them together, but we have to add them together as 1 over. So 1 over the resistance in parallel equals 1 over R1 plus 1 over R2 plus 1 over R3. Now, there are 2 ways to solve. You can solve it using fractions. You can solve it using decimals. I strongly encourage you to solve it with fractions. It's easier. Unless you just hate fractions with every single fiber of your being. If you just hate fractions, you refuse to do them, you would rather chop off a finger than do fractions ever again, then do decimals. But fractions are going to be easier most of the time. Not all the time, most of the time. I try to make the numbers so that they work out to be reasonable-ish. And when they become unreasonable, it'll be pretty obvious to turn it into a decimal. But right now, these are all reasonable-ish numbers, so I would not turn them into decimals unless you just feel like deep in your soul you have to. Okay? All right. So we need a common denominator to add these up. If you get a common denominator, the common denominator between 1, 2, and 3 is 6. So 1 over 1 multiplied by 6 over 6 to get over 6. So this becomes 6 over 6. We have to multiply by 3 over 3 to get that into 6 for a common denominator. And we have to multiply this by 2 over 2 to get a common denominator of 6. We're going to add that up. And we're going to get 11 sixths. And I know you're saying to yourself, you're like, Mr. B, this is not better. Why is 11? I don't know what 11/6 is. That's not better than that. Why am I doing this? Here's why. Because this is not the answer. 11/6 is not the answer. That's 1 over R. I don't want 1 over R. I want R. Here's why you leave it in fractions. The reason why you leave it in fractions is because now all you have to do to get it in R is this. Flip. Flip. R equals 6/11. And now if you want to turn it into a decimal, now you can. That's why I suggest leaving it in fractions. Now, if you are absolutely atrocious at fractions, if you looked at this and you're like, then turn it into decimals. But let me show you how to do it in decimals. Okay? 1 over R equals 1. So 1 divided by 1 is 1. 1 divided by 2 is 0.5. 1 divided by 3 is 0.3 repeating, but we'll just go ahead and round it to 0.33. Or you could do 0.3 or whatever you want to do. Okay? Add that up. That gives you 1.83. Now, that is not the answer. I don't want 1.83 as 1 over r. I want just r. So what I have to do is I have to do what's called taking the inverse. And you do this on your calculator. So find your calculator. Borrow one from me if you need one, because I don't know where it is on your phones. Okay? But I know where it is on these calculators. So if you need to borrow a calculator, come borrow one real fast. But you'll want to see where this is on the calculator. Okay. Where are you on here, calculator? Where are you? Don't know where it is on here. There it is. Okay. You're looking for a button called the inverse button, and it is either an x to the negative 1, or, I'm going to have to zoom in here so you can actually see it, or it's a 1 over x. It'll be one or the other on your calculator. It'll either be x negative 1 or it'll be 1 over x. Okay? All you have to do when you get to that point, all you have to do is do 1.83, hit that button, hit equals, there it is. Now, you are not going to be as accurate as if you do decimals.
Yeah, it's a little bit different.
Yep, we got 0.55. That's not the end of the world, okay? But just keep in mind it's not going to be as accurate. And there you go. That's how you do those kind of problems.